Hi, this is Kevin Shryock coming to you with the homework help for the question you submitted. So I was given the question that says, given a 250 Newton force at an acting acting at an angle, so a little bit of typo there, 250 Newton force acting at an angle of 120 degrees with respect to the positive x-axis, find the vertical y and the horizontal x components. Lots of words. Let's break this down. Well, what's happening? I've got a force. It's going at an angle. My mind is already thinking picture. I am just that kind of guy. I'm thinking picture. So let's go ahead and put in a couple of lines. Let's make a coordinate plane, because a coordinate plane is going to keep everything nice and organized. So if that is my first line, that is my second line. Where are we talking about? Well, let's see, I'm looking at a 250 Newton force acting at an angle of 120 degrees with respect to the positive x-axis. Well, this is my positive x-axis. 120 degrees is going to take me, well, past 90, and then about 30 degrees past 90 is going to give me something right about there. Alright, and this is my 120 degrees. This is my y-axis. Alright, what is it asking for? Find the vertical and the horizontal components. So the vertical and horizontal components, well, this vector has not only a direction but a magnitude. The magnitude is 250 newtons. Let me zoom in a little bit here. Oop, too much. That's good. So I've got 250 newtons acting on this this vector, or 250 newtons as a vector going 120 degrees out. If I was going to break this down into its components, well, its components are going to be the x component, which is going to be what goes along my x-axis, and it's going to be something right about there. And then it's going to have its y component. The y component is going to be what I have to do to go up to it. And I'm going to write it right about there. So there we go. There is my y component, and horizontally is my x component. So how would I find out what the components of this is? Well, the 120 degrees isn't helping me right now because it's not inside my triangle. And my trig identities, my trig techniques are going to be talking about opposite over hypotenuse and adjacent over hypotenuse. And right now I don't have an opposite angle to this 120 degrees. What do I do? Well, I can take and figure out what the angle is inside of this. I could say that the angle on the inside, let's call it theta, so I can do my math to the side. So let's call this theta. There we go. If I was going to talk about theta, I know that 120 degrees plus my theta gets me an entirely straight line. So I could write over here that the straight line's angle, which is 180 degrees, must be equal to the 120 degrees, 120, not 12, 120. 120 degree angle plus my unknown angle theta, which if I just do some simple arithmetic is going to get me to a 60 degree angle. Alright, so I've got a 60 degree angle right on in here. Now, it's okay to use this so long as we recognize that the 60 degree angle is coming up from the negative x-axis, and this is going to be very important when we talk direction later in this problem. But for right now, I'm good with just saying that that's 60 degrees, and we'll check the direction with our final answer. So how would I figure out the component of this force? Well, let's label this as the force in the x and the force in the y. The force in the x is now going to be my adjacent side over this known hypotenuse of 120 newtons. So I could say that the force in the x over the total force is equal to the cosine of my angle theta. Solving this for force, the total force, or solving this, excuse me, for the x component would get me f of x equals f cosine theta. And I can just plug things in at that point. I can say that f of x is equal to 250 newtons cosine of theta. Oh, cosine of, I already know what theta is, let's just plug it in. Cosine of 60. And that's going to get me something out to, instead of typing in my calculator, I'll just take a look at my notes. 125, so negative 125. Now, if you didn't get the negative, the reason why I have a negative is because I'm looking up here where that f of x is pointing. And the f of x is pointing to the left. And the left is going to be my negative direction. If you want the math to work out where it gives you that negative all the time, if you plug in 120 for your angle here, if you were to do instead, so we'll say the negative of this equals the positive 250 cosine of 120, the original angle it gives us, then that would get you a negative x value, and the math would work out just perfectly. But I'm more of a visual guy, so in the case that I don't know what cosine is, we might as well just look for things that are similar and then reference the picture when talking about our directions. So this would be one component of our answer. Negative 125 newtons is going to be my x component of the vector. Once we've already done it for the x, doing it with the y is no different and is just a little bit faster. So let's knock that out. The y direction, the force in the y, is our opposite side. So force in the y over force, the total force, is equal to this time sine of the angle theta. So solving that out gets me f of y is equal to f sine theta. Sine theta. And then I can plug things in and just say that f of y is equal to 250 times sine of your choice, either 60 or 120. If I do 60, I have to reference the picture. If I do 120, I don't. So this gets me 250, this gets me, what does that solve out to be? That comes out to be 216, so 216 newtons. And before we submit it, we've got to make sure that the direction is true, and it looks like, yeah, the y component of that original graph is going to be pointing us up into the y direction, so that's going to be a positive y. So I'm okay with saying that it's going to become a positive 216 newtons. If you plugged in 120 for your angle theta, that would have given you a positive y as well, because it's going to be pointing you still up in this graph. So at the end of this, I do want you to kind of think about and choose which way is going to be better for you. Do you prefer to just be a very visual person where you're going to rely on the picture, you're going to put the angle where it makes sense to you for your trig properties, or do you want to do just the pure math where you work with the angle? Whichever you do is fine, and it's both going to get you the same answer. You just have to make sure that you're consistent, because if you use this inside angle and then don't go back to check for the direction, you're going to put down the wrong sign, and it's going to make all that work for nothing. So let me zoom out so you can have a nice takeaway. We've got our f of x is equal to 125, negative 125. And we've got our f of y is 216. In our original answers, that would put us at 125 and 216, number C, or letter C. And that would be our final answer. Alright, hope you enjoyed.